Okay, so today we are going to be looking at midpoints and endpoints, which is day 8 in our notebook. Or in our little, notes. It's notes. We can call it a notebook. All right, so day 8, locating midpoints and endpoints is what we're looking at. Let me get this to fold where I can still see everything. There we go. The midpoint we've already defined in class before. It's the point that divides a segment exactly in half. And you may or may not remember, but we said we use tick marks to show congruence. That is not the only way you can show congruence, but it is a way that you can show congruence. So if I ever show you a segment and I say, do you have a midpoint? If it doesn't have tick marks on it and your answer is no because I don't have tick marks, that may not be the correct answer because there may have been some algebraic way you could have proven that you had a midpoint, okay? So tick marks are not the only way to show congruence. And remember that word congruence means has equal measure. So the left side of that point is equal in measure to the right side. They both have the same length. Okay? So the other ways we could show it is we could show it algebraically, that the two sides were equal. It can be shown algebraically or given in the direction. So when you get a worksheet or a review packet or the test or a quiz, is it going to be important to read directions? Yes, because it might say in the directions, point P is a midpoint, right? If you don't look at the midpoint, if you don't read that and you're just looking for tick marks, it may not have tick marks, but they did tell you have a midpoint. Okay? So don't always just look for tick marks. There's also algebra, and there's also just, they might give it to you written in the directions. Okay? All right, the next thing we're going to talk about is what's called a segment bisector. When you dissect something, like in science class, you're cutting it apart into a whole bunch of little pieces. When you bisect it, that's when you're cutting it into just 2 pieces. Okay? And it's going to be 2 equal pieces. Okay, so a segment bisector is a point, a segment, a ray, a line, or a plane that intersects a segment at its midpoint. Okay, so for example, we could say point M, which we know is the midpoint because we see the tick marks. Point M is a midpoint of segment AB, but point M is also a segment bisector of segment AB. Think of it like scissors, right? It cuts that segment right in half. Okay? It could also be a segment. So instead of just looking at just point M, I could look at segment MC, just this little bit right here. That segment would be a segment bisector of segment AB. Okay? I could also do segment CD. I could go this whole way. Segment CD is a bisector of AB. That means segment CD is the scissors to AB. So this one is cutting the second one in half. The segment bisector itself, CD, doesn't have to be bisected. If I take those arrows off and I look at just that segment, we can see that it appears this side is much shorter than this side here. So CD isn't being bisected. AB is being bisected. CD is the bisector. It's the one doing the bisecting. It's cutting in half. Okay? Or instead of having a point or a segment, we could have a ray, which just means you would start at any of these points and then just keep going forever. So I could go from C towards D and have a ray. So ray CD could be an angle bisector, or sorry, a segment bisector. That was a little preview of what's to come when we do angles. We'll have angle bisectors. Okay. And then you could also be a line, so you could extend both directions, and a line could cut that segment in half. And then you could also do a plane. A plane would be hard to add to this picture. If I wanted to show what that would look like, it'd be easier to draw a new plane. If I drew a new plane, put a little M in the corner, and then a segment, and then it would extend an equal distance on the other side. So if this side was equal to this side, and maybe this, we've already used A, B, C, D, and M, we could say this is maybe E, F, and G. We could say that plane M is a segment bisector of segment what? What would I name the segment? EG, right? M is the plane in this case. Now, if this is all one picture, that's okay, even though I told you you can't repeat letters. But here, this M is representing a point, and this M is representing the plane. This one is not a point. A lot of you, we had one of the homework assignments that had you describing a plane M that had an A and a C in it, and then B was not in that same plane. And a lot of you kept calling it plane ACM. But M is not a point, so you can't use it as 3 letters to name the plane. It would just be plane M, just the 1 letter. Okay? All right, here's an example. It says given point M is the midpoint of RS. Complete each statement. Okay? Number 1, if RS equals 10 inches, then what does SM equal? Okay? The first thing I want to do, just because I don't want to mess my brain up, is I'm going to sketch this given part right here. Point M is the midpoint of segment RS. So I'm going to draw my little segment with an R and an S. And it tells me that M is right in the middle, which means I'm allowed to add tick marks. Okay? All right, so now RS is 10. I'm going to add that to my picture. R to S is 10 inches. How far is it from just S to M?
5.
5, right? If the whole thing is 10, each side has to be 5 inches. Now if I look at number 2, it says RM is 12, but if I look, it says no, RM is 5. Okay? In geometry, a lot of times what they'll do is they'll use the same picture over and over again for multiple problems, so that way you don't have to keep, on your worksheet, they don't have to keep adding the picture over and over and over again. So definitely when I'm doing my assignment, if I'm in a situation like that, I want to be using pencil, so each time I can go back to my picture and erase what's there so I can start fresh. Okay? Because now when I start this fresh, I go, okay, now RM is now not 5 inches, but it's 12 yards from R to M. How far is it from M to S?
12.
Also 12 yards. And how far is it from R to S?
24 yards.
24. Very good. Okay. Now, we have to throw some algebra in there. Find the value of y if Q is a midpoint of PR. So if we hadn't have read any directions, we might assume Q is in the middle, but we're not allowed to just assume, right? It looks kind of like it's in the middle of P and R, but we can't say it really is until we see here that it says Q is a midpoint of PR. So that means I'm allowed to go like this and like this. And that tells me, if I have this given, this information given to me, imagine we were doing a proof, then I'm allowed to use the definition of midpoint to say if this is in the middle, then the two sides must be equal in length. So the distance from PQ must have an equal length to QR. And I can write this, if this is given to me, using the definition of midpoint. Okay, we're not going to do a proof today, but just so you know, that is something that you might someday see in a proof. We're using the idea of midpoint, and then you're going to use what its definition is so that you can continue. Next would be, what would we do next if this was a proof? Yeah, we would substitute. We know how big PQ is because look, it's given to me in the picture. Sometimes things are given in pictures. Okay, PQ is given to me in the picture. So if it was a proof, I'd have to put given, PQ equals this. And then I could substitute it in here. 9y minus 2 equals, and then this is also given to me. QR is 14 plus 5y, so I can substitute that in. So those would both be substitution. What would I do next?
Addition.
What would we add on both sides?
2.
Okay. Is that the only thing we could have done?
No.
No, we could have moved the 5y first, right?
Yes.
Or we could have moved the 14 or the 9y, whatever, right? They're all the same, depending on how we're trying to go. All right, now what am I going to do?
Subtraction.
Subtraction property of equality. I'm going to subtract what? 5y. And I end up with,
4y equals 16.
and then next,
Division here.
division property of equality. And I end up with y equals 4. So that's the first part it asked me to do. It said to find the value of y. Y equals 4. That part's done. Then it says, okay, let's find PQ. Okay, so PQ, over here, from P to Q, we know it's 9y minus 2. I'm going to substitute in. My y is 4. And then I'm going to simplify. 9 times 4 is 36. And then I'm going to combine like terms. 36 minus 2 is 34. So now, it's real tempting to go, okay, QR is 34 and not do the math. Why should we still do the math anyway? Just to check, right? I know this better be 34 because they're supposed to be equal, right? If I do the math and I get something that's not 34, I need to come back over here because I probably did something wrong in my algebra, okay? What's really nice about a lot of geometry is if you check your work, you'll know already when you turn something in, I should have 100 because I checked all my work. Everything worked out, okay? So if I come over here and I do 14 plus 5 and I substitute in the 4, then I'm going to simplify. 5 times 4 is 20. And then I'm going to combine like terms. 14 plus 24 is
34.
So we can feel confident. Woo! We did it right because we got 34 for both of them. Another big hint is you should never get a negative for your final answers. It's okay to get a negative for the variable as long as when you plug that variable in, you still end up with an overall positive answer. Because you can't have negative distance. If I walk forward 4 steps, and then I walk backwards 4 steps, the step counter in my watch doesn't say I'm now at 0. I'm now at 8, right? Because both of them are positive distances, whether I was walking forward or backwards. If you've ever seen Ferris Bueller's Day Off, you understand that you can't drive a car backwards and take mileage off the car. Okay, it doesn't work that way. Distance is always positive. Okay, so the distance from a point to another point is always going to be positive. You'll rarely see negative numbers in geometry unless it's like a variable that you're going to plug in somewhere else. Okay? Now we're not quite done because it still says to find PR. How far is it from P to R?
68.
Yeah, we just add them to, do you remember what the postulate's called if we were doing a proof? When you add this side to this side and you get the whole thing? You're adding this segment to this segment. So the two segments are being added.
Addition.
Segment, addition, postulate. Postulate. The segment addition postulate allows us to say that PR is 68 units. Okay? All right. Let's move on and do another one of these examples. Wasn't it? Okay. I'm going to pretend that was genuine.
That's really good. That's from the heart.
I think so. Okay. Your turn. Given point M is a midpoint of segment FG, find the value of Y, then F to M, then M to G, then F to G. So I'm going to move that to the ceiling so you can't see what I'm doing, and we're all going to try to do it together independently, together apart, and then we'll see how we all did. One more minute. All right, those of you who finished, what did we get for Y?
-1.
-1. What did we get for F to M?
8.
And for M to G?
8.
And the whole thing? 16. So I just finished telling you you hardly ever get negative numbers in geometry, and then I gave you a negative number, right? But it was the variable, and when we plugged it in, we did get a +8, and we did get a +8, so we could feel confident we did our answer correctly. And then 16, okay? Remember, when you move from one side of the equals to the other side, you do the opposite, right? So -3y, we added 3y to both sides. And then here, +13, so we're going to subtract 13, giving us that -8. Divide both sides by 8, and you get the -1. Okay? All right, the next thing we're going to talk about is midpoint on a coordinate plane. Okay? So I'm actually going to sketch a little picture on my makeshift whiteboard that I have here. I don't know if this marker works or not. Okay. So if I were to have a coordinate plane.
Do we draw that?
No, you don't have to. If you have scratch paper somewhere, if you want to do it on the back of your notes, you can. Okay? And then I have a segment here and here. Let's say it has endpoints A and endpoints B. The midpoint is going to be exactly in the middle. Yes? Wherever the middle lands. Okay? So if I look here, it tells me that the midpoint is going to be the average x value of my two endpoints and then the average y value of my two endpoints. Okay? So if I think of my two endpoints, a lot of times in geometry, we will think of our points as variables, obviously, as x's and y's. So this end is an x and a y. And this end is an x and a y. And then our midpoint, I'm actually going to erase my coordinate plane because it's going to be where I want to be writing. But remember, it's really there. Okay? All right, and then my midpoint is also an x and a y. Okay? Now, to distinguish them, a lot of times what you'll see in formulas is they'll say, oh, you have one end, so that's my x1, y1. And then you'll have the other end, so that's x2, y2. And then you have your midpoint, and sometimes you'll see it as x with a little m and y with a little m. It's kind of hard to do with this big fat marker to make that look like an M. Okay? So, oh, I actually have thinner markers. When we look at finding the average of the x values of the endpoints, I have two endpoints, so I have two numbers that I need to average together. How do I average these two numbers together?
Add them and divide them.
Add them and divide them, right? By how many?
Two.
Two, because there's two numbers. And then I'm going to do the same thing with y's. I'm going to add them and divide them, right? So, for example, my first problem is I have find the midpoint between 7, 4, and 1, 0. Okay, so if I were to think of my graph, if I say one end is my 7, 4, and the other end is my 1, 0, and I'm trying to find where is the midpoint right in the middle. Okay? That's my goal. So y'all said we're going to take my two endpoints, my two x's, we're going to add them together and divide by 2, and that's going to give me the x for the midpoint. Okay, so my x for the midpoint is going to be my two x's added together and divided by 2. So my 1 and my 7 added together and then divided by 2. What's 1 plus 7? 8. And 8 divided by 2?
4.
So I know that's going to be my x value for the midpoint. Okay? My y, I'm going to do the exact same thing, the y for the midpoint. I'm going to do the same thing but with the 0 and the 4. So my y for the midpoint is going to be my 0 and my 4, the y's, added together and then divided by 2. 0 plus 4 is
4.
Divided by 2?
2.
Okay. And so the point 4, 2 is the midpoint of 1, 0, and 7, 4. Notice I wrote it with parentheses and a comma. If you don't put parentheses and you just put 4, comma 2, you're not writing a point, you're just listing two numbers. So make sure you use correct notation and write it as a point. Okay? Alright, so now when we do the next one, I'm going to follow the same process. My x from the midpoint, I'm going to average my two x's together. What are my two x's?
6 and negative 4.
6 and negative 4 divided by 2. What's 6 plus a negative 4?
2.
2, and 2 divided by 2 is?
1.
And then my y for the midpoint, what two numbers am I going to average?
12 and 8.
12 and 8. So 12 plus 8 divided by 2. What's 12 plus 8?
20.
Divided by 2?
10.
10. So my midpoint is the point 1, 10. Look at my nice notation there. Right? It says find the missing midpoint M or endpoint A or B. So I already have an A here, I already have a B here, so I knew I was looking for the midpoint. Here again, I already have my A, I already have the B, so I know I'm looking for my midpoint. Okay? So we're going to follow the same exact process for number 2. My X for the midpoint. What two numbers am I going to average?
3 and 9.
3 and 9. 3 plus 9 divided by 2. 3 plus 9?
12.
Divided by 2?
6.
6. And then what two numbers am I going to average for my Y?
16 and 8.
16 and 8. 16 plus 8?
24.
Divided by 2?
12.
Easy peasy, right? Okay, it gets a little complicated on number 3 and number 4, because notice on number 3 they gave me the A and they gave me the M. Thank you. I forgot the 1 for the 12. And I didn't put a pretty box around it. Okay, on number 3 we get a little bit more complicated, because they gave me an endpoint and they gave me a midpoint. I'm missing the other endpoint. Okay, well let's look at it. Okay, so what they gave me is they gave me one endpoint was 3, negative 5. A was 3, negative 5. So A is 3, negative 5. And they gave me the midpoint. My midpoint is negative 1, 2. Okay? And I'm looking for the other x value, right? I need to know what is this x2, what is this y2. I know if I average the 3 and whatever this x2 is, if I add those together and divide by 2, it's going to give me what? Negative 1, right? If I average these two together, it should give me this negative 1. Okay? So if I average these two together, it should give me my negative 1. Okay? So to average those two together, I'm going to have my x2 plus the 3 divided by 2. Right? You add them together and divide by 2. That's how you find the average. And that's going to equal negative 1. So it's a little bit different, right? Instead of already having everything on the algebra side and it's already set equal to the variable, it's not set equal to my variable that I need to find. So I'm going to have to figure out what that x is. Okay? So what we're really doing here is we are saying that my b value, my bxm, or xy, if I take these two and add them together, let me zoom back in. So I've got a and b and my midpoint m. If I take my x's and average them together, so add them together, 3 plus x, and divide by 2, I know that's going to give me, right, if I add them together, it's going to give me my midpoint, negative 1. How do I solve this? Good. Multiply both sides by 2. My multiplication property of equality to get rid of that divide by 2. I'm going to multiply by 2, which is going to leave me with just 3x equals, or 3 plus x. Negative 1 times 2? Negative 2. Then what am I going to do? Uh-oh.
Subtraction POE.
I'm going to subtract what?
Subtraction POE, subtract the 3 on both.
Yeah, I'm going to do subtraction POE, property of equality, and subtract the 3 on both sides. And x is going to equal negative 5. Then we would have to do the same thing with the y's, right? So then, if I want to do the y's, I know that this y averaged with this y is going to equal the middle y. So these two, this negative 5 plus this y2, divided by 2 is going to equal 2. Does that make sense?
Yes.
Okay. So negative 5 plus y divided by 2 equals 2. So negative 5 plus y divided by 2 equals 2. What am I going to do first?
Multiply them.
Yeah, same thing I did last time. I'm going to multiply. And then I'm going to add or subtract over. So multiply both sides by 2. Negative 5 plus y equals 2 times 2 is 4. Then what? Addition POE, because that y value was a negative, so to do the opposite, we have to add it. And I end up with y equals 9. Oops, I shouldn't have put a box around that, but since I did, I'll put one around that also. But I should write my answer as a coordinate because it said find the missing midpoint or endpoint. So I'm trying to find a point. And I know I've got AM, so I know this one's called B. Its x value is negative 5. Its y value is 9. This is what my answer should really look like. This is what I expect your answers to look like on your assessment. It should be written as a point with parentheses and commas. Okay? Alright. Number 4, I'm missing point A, right? So I'm missing the endpoint. So in this one, if I were to fill this one in this time, what I've got is erase. So let's see. This time, M is negative 5, 10. And B is negative 8, 6. And I'm going to be looking for A for this XY. Yes. Okay? All right. How should I start if I'm looking for the X? If I want to find this X right here. The average of these two, and what's it going to equal? The average of the outside points equals the inside negative 5. So if I take the X and the negative 8 and I average them together, X plus a negative 8 divided by 2, that's how you average them, it's going to equal the middle number, negative 5. X plus negative 8 is going to equal negative 5. Okay? X plus negative 8 equals negative 5. Divided by 2 equals negative 5. What do I do first to solve? Multiply both sides by 2. And then it's x plus a negative 8. Is everybody okay if I change that to x minus 8? So that's the same thing? Equals negative 5 times 2 is negative 10. Now what am I going to do? Addition property of equality. And x equals 2? Negative 2. All right, and then the last one, we just still need to find y. So if I come back here, this time I want to find y. So when I look at my y's, what is my equation going to look like? Y plus 6 over 2 equals what? 10. Y plus 6 over 2 equals 10. Y plus 6 over 2 equals 10. Oops, I went the wrong way. Y plus 6 over 2 equals 10. What am I going to do first? Multiply both sides by 2. Y plus 6 equals 20. Then what? Subtract. Subtraction property of equality. And y equals 14. So then my answer is a negative 2, comma 14. I don't know why I switched marker color there, but okay. Now, here's a quick way to check. And you might go, Ms. Bishop, why didn't you show us that in the first place? If M is truly a midpoint, I like to do something sometimes called the column method, where I take my two endpoints, my 6, 12, and my negative 4, 8, and then I put my midpoint in the middle, 1, 10, and I say, is it truly right in the middle? Because when I have my x's stacked, it makes it a little bit easier to say, well, to get from 6 down to 1, I have to go down 5. So if I go down 5 more, do I get to the right place? Yes, I do. Yeah? From 12 down to 10, I went down 2. If I go down 2 more, I get to 8. I can be confident that this is correct. Okay? Same thing here. If I've got 3, 16, and my midpoint is 6, 12, and then my other endpoint is 9, 8, 3 plus 3 is 6, plus another 3 is 9. 16 minus 4 is 2, minus another 4 is 8. I can feel confident I did this correctly. Okay? It also works really well for actually just doing this problem and not having to do all of this math, because watch how easy it would have been, and you wouldn't have had to do any of the algebra. My first point is 3, negative 5. My middle point is negative 1, 2. And then my third point, we did all this algebra, we know it's negative 5, 9, but if we didn't want to do the algebra, we could say, well, to get from 3 down to negative 1, I have to subtract 4. If I subtract another 4 from negative 1, oh, look, I'm at negative 5. I didn't have to do any math at all. Well, subtraction. From 5 up to 2, I have to increase by 7. So if I increase 2 by 7, I'm going to be all the way up to 9. And I only had to do that much work instead of this much work. I showed you that second because I wanted you to see the math. Same thing here on this one. If I'm trying to find A, I know my midpoint is negative 5, 10. I know my other end is negative 8, 6. I can say, well, to get from negative 8 to negative 5, I have to go up 3. So go up 3 more. Now I'm at negative 2. To get from 6 to 10, I have to go up 4. So go up 4 more. Now I'm at 14. Negative 2, 14. A little bit easier that way, but it's important to see the actual algebra behind it so you understand how we're getting there. Okay? Does anybody have any questions over midpoints or endpoints? All right. You do have an assignment that you can work on that won't be due until the next class day.